Question number 16 says that find the direction in which a straight line must be drawn through the point -1, 2 so that its point of intersection with the line x plus y is equal to 4 may be at a distance of 3 units from this point. Okay, so let us try to understand it with the help of a figure that what is given to us. Okay, so suppose we are having a line, okay, with respect to this system. So x dash y o y dash. Okay, so let us take our line AB is x plus y is equal to 4. So if you will plot, you will get a line something like this. Okay, A B, so it is x plus y is equal to 4. So if you need to be a little bit perfect, so you can just plot a line. Okay, general rough line can be plotted, and the point I am given here is -1, 2. So -1 is toward this side, so point -1, 2 will be here. Okay, so he says direction in which a straight line must be drawn through this point. So you have a draw, right, that is intersecting this curved line. So means, say the situation is something like this, that a line is passing through this point and is intersecting, suppose this line at HK. Suppose I take the point as HK. Okay, such that the means we are given that such that the line through -1, 2 it intersect your given line x plus y is equal to 4 at the point q coordinate HK. Okay, right, and this we are also given that this distance PQ. Okay, we are also given, let me show it to you very clearly, that this distance PQ, this is 3 units. Okay, it is given here that this distance PQ is 3 units. Okay, so I am given that this distance PQ is 3 units. Okay, now we need to find the equation of line PQ. Okay, so let us find means I just need a point, that I just need the coordinates of this point Q. So we will find this coordinate of point Q. Okay, now see clearly this point Q, it lies on line AB, so that means it is satisfying, right? So I'm having x plus y is equal to 4, so I get h plus k is equal to 4. I will get h is equal to 4 minus k. Okay, now let us use whatever is given. PQ is your 3 units, and distance, you know that using the distance formula, x2 minus x1 whole square, y2 minus y1 whole square, this is equal to 3 units. So let us put back the values. It will be your h minus -1 whole square plus k minus 2 whole square is equal to 3. So it becomes your h plus 1 whole square. So we get it as h plus 1 whole square plus k minus 2 whole square is equal to 3. Okay. So when we will square these sides, what we will get? We will get h square plus 1 plus 2h plus k square plus 4 minus 4k. Okay, this is equal to 9. We have squared this, so we will get this equation as h square plus k square plus 2h minus 4k. So it is 4 plus 1, that is your 5, and 9 minus 5 will be 4 is equal to 4. Okay, now let us put this value of h, which is 4 minus k here. So it is 4 minus k whole square plus k square plus 2 into 4 minus k minus 4k is equal to 4. So it will be a equation in terms of your k, quadratic equation. So 16 plus k square minus 8k plus k square plus 8 minus 2k minus 4k minus 4 is equal to 0. Okay, so what we get? We get it as your 2k square, okay, minus 8k minus 6k. So that is your minus 8k, and minus 6k it is 14k, right? And this is 16 plus 8, 24 minus 4 is plus 20 is equal to 0. So I can reduce it a bit further. K square minus 7k plus 10 equal to 0. So the factors are 5 to the 10. So then clearly we can go by k square minus plus 10 equal to 0. So I can write it as k minus 2 into k minus 5 equal to 0. So I get k as 2 and 5, or 2 or 5. So when k is 2, what is h? So h I get 4 minus 2, that is 2. So the point Q has coordinate 2, 2, and if k is 5, your h is your 4 minus 5, that is minus 1. So point here is your minus 1 comma 5, as the coordinates are hk, right? Now I need to just get the equation of line also. So equation of this line joining points x1 y1 and x2 y2, we will use the 2-point form. Y minus y1 equal to y2 minus y1, x2 minus x1 into x minus x1. So you know that there are two conditions. First, the point is minus 1 2, and q is having 2 2, and here p is having minus 1 2, and q is having minus 1 5. So I will use this equation y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1. So y minus 2 is equal to 0 into x plus 1. So I think it is clear that y is equal to 2. So that means you clearly know that this line is parallel to which axis? X axis. Okay. So which line? PQ. Line PQ is parallel to x axis. And for the second condition, y minus y1 equal to y2 minus y1, x2 minus x1 into x minus x1. So what do I get? Y minus 2 is equal to, it is just to be careful, it is the point is minus 1 2 and minus 1 5. Okay, so it is 5 minus 2, and it is your minus 1 minus 1, and this becomes your plus 1. Okay, so we get this you get that it is something 3 upon 0, which becomes your infinity. Okay, but as we know that we cannot make it as infinity, so to reduce it to the other form, what I will do is to make it 0, I will shift it to other side, means cross multiply. Let's cross multiply. So it becomes is equal to x plus 1. Now what will happen? This term will reduce to 0, and the equation will be you will get the equation as 0 is equal to x plus 1, or I can write that x plus 1 is equal to 0, or x is equal to minus 1. So when you know that x is equal to minus 1, then what kind of line this PQ is? Your line PQ is parallel to y-axis. Okay, so here line PQ is parallel to y-axis. Question number 19 says that If the lines y is equal to 3x plus 1, 2y is equal to x plus 3 are equally inclined to this line. Equally inclined means this line 1 and 2, they make equal angle with this line. Means 1, the angle made between 1 and 3 is equal to angle made between line 2 and 3. Okay, equally inclined, that is the meaning of that. Okay, find the value of m. Then you have to find the value of m. Now since we are supposed to or given the condition of equally inclined, I will use that formula of tangent theta. Okay, so your given lines are, we will first of all check the slopes. So slope of y is equal to 3x plus 1. This line is slope is having, it is having your slope as 3. Okay, and suppose this is your we take it as like m2. Okay, and slope of this line, slope of line y is equal to x plus 3 upon 2. Okay, I'm expressing this. So here slope is coming out to be half. Okay, so which we call it as your half, we take it as your, again it is your say m3. Okay, and the slope of third line y is equal to mx plus 4, it is clear that we are having your say m, so I'm taking it as m1. Okay, so let us apply the formula for according to condition or question. What is the question is that the angle made between 1 and 3. Okay, so angle, we will use the formula of your we know that tan theta is m1 minus m2 upon 1 plus m1 m2. So suppose we are finding the angle between 1 and 3. That means the question is angle between 1 and 3 is equal to angle between 2 and 3. Okay, question is that means these lines are equally inclined. So we will apply the formula and use the slopes of, in place of m1 we can take the slope of your either you take the common one 3 as say we have taken is as m1. So the formula will be like m1 minus m2 upon 1 plus m1 m2, and here I will take m1 minus m3 and 1 plus m1 m3. Why? Because the slopes of the lines involved 2 and the these lines 2 and 3, so we are having it as your m1 and m3. Okay, and here it is m1 and m2, right? So let us start putting the values. M1 here is your m and m2 here is 3 upon 1 plus 3m. This mod is given as m minus half upon 1 plus half m. So we get it as m minus 3 upon 1 plus 3m is equal to plus minus times 2m minus 1 upon your 2 plus m. Okay, 2 plus m. So this is your equation. Now two cases arise, again one with this plus and one with this minus. So let us take the first case. M minus 3 upon 1 plus 3m is equal to 2m minus 1 upon 2 plus m, and m minus 3 upon 1 plus 3m is equal to minus 2m minus 1 upon 2 plus m. So cross multiply it is 2m minus 6 plus m square minus 3m is equal to 2m plus 6m square minus 1 minus 3m. So I think same things will get cancelled out, and now we will arrange the terms to one side. So what do we get? We get like your equation as your, the condition is that it is your 6m square and minus m square, that is your 5m square. Okay, we are going to that side, and this also gets cancelled, 5m square and your minus 6 is equal to minus 6 and plus 1, that is your minus 5. Okay, so implies m square is equal to minus 1, and you know it is not possible. Okay, square of anything is not possible. Okay, now case number 2 is, let us cross multiply, and you can even make it simpler if you are not comfortable with this negative sign. You can just equate m minus 3 upon 1 plus 3m with 1 minus 2m upon 2 plus m. Cross multiply. So 2m minus 6 plus m square minus 3m is equal to 1 minus 2m plus 3m minus 6m square. So we get it as your, let us bring everything to one side. We will get a quadratic equation like 6m square and m square is 7m square, 2m minus 3m is minus m, okay, minus m from this side, and plus m from this side. When we'll come to this side, we will get minus 2m and minus 6, and minus 1 will come here, minus 7 equal to 0. So you can use that quadratic formula minus b. So minus of minus 2 is plus 2 plus minus. Discriminant is b square minus 4ac plus 4 7s are 28, 28 7s are your 196, and this is your upon 2 7s are 14. So this becomes 2 plus minus. So this is 200. 200 can be written as 10 root 2 upon 14. So if I solve it bit, you can just leave it, or you can cancel out the terms, like 1 plus minus 5 root 2 upon 7 is the required answer. If the sum of perpendicular distances of a variable plane from the lines, these two lines are there, is always 10, show that we must move along a line. We must move along a line. That means that the result we will get is a equation of a line, an equation of the form of your ax plus by is equal to your plus c equal to 0, something like this. So sum of perpendicular, you know the formula for perpendicular distance of a point, say x1 y1, from any line of the form ax plus by plus c equal to 0 is given by d is equal to ax1 plus by1 plus c upon under root a square plus b square. Okay, now let us write the lines firstly in this form. So it is x plus y minus 5 equal to 0. These are already expressed, and this is your 3x minus 2y plus 7 equal to 0, and the point here is xy itself. So according to question, I will apply this formula, but in place of x1 y1 you have to take just xy. So the perpendicular distance will clearly be the same equation, x plus y minus 5, right, upon under root, your coefficient here is 1 and here is 1, so 1 square plus 1 square. This is equal to okay, sum of distances means plus the second distance 3x minus 2y plus 7 upon under root of 9 plus 4. This is always equal to 10. Okay, so what we can do is that it is your, say, plus minus, because I can open any of the mod. So plus minus x plus y minus 5 upon, it becomes root 2. This becomes your plus minus 3x minus 2y plus 7 upon under root 13 equal to 10. Now what we can do is, we will get actually 4 equation, which is set of 4 equations. Now how will you get the 4 equations? Firstly, you will take this first equation as positive, second as positive equal to 10. Then both sign negative to this side equal to 10. Then one can be plus, second can be negative equal to 10. And first can be negative and the second is positive, then equal to 10. But whatever result you will find from here will represent the equation of line, that is ax plus by plus c is equal to 0. First case we can take, or this question is, we can take the distance x plus y minus 5 upon root 2 plus means both the cases we are taking as positive, plus 3x minus 2y plus 7 upon root 13 is equal to 10. I considered both the signs positive, so the LCM will be like root 13 into x plus y minus 5 plus root 2 into 3x minus 2y plus 7. This is equal to your 10 into 2 root Root 2 into root 13 is root 26. So just open it, root 13x. Okay, root 13x plus, or you can just leave this question as it is, otherwise the length of the question will be increased. But you find that whenever you will open it, you will get your means equation in this form. Okay, so if you want to open it, you can open, otherwise if I open it, it will become your root 13x, okay, plus root 13. It's just 13. Okay, so it is root 13x plus root 13y minus 5 root 13 plus 3 root 2x minus 2 root 2y plus 7 root 2 is equal to 10 root 26. Okay, so what we get is as your root, means let us combine the x coefficients, so root 13 and plus 3 root 2 into x plus root 13 and minus 2 root 2 this y. Okay, minus 5 root 13 minus 5 root 13 plus 7 root 2 minus 10 root 26, this is equal to 0. So this is the first equation, which is of the form of ax plus by plus this is the complete constant term, so which is equation of straight line. Okay, so second one, when you will take it as, means you can consider the case number 2. You can consider that you can take this the line x plus y minus 5 as positive and this 3x minus 2y plus 7 this as negative. Okay, then third line you can plot by taking x plus y minus 5 as negative and 3x minus 2y plus 7 as positive, and in third case both you can take negative. In last case x plus and both negative. Question number 21 is find the equation of the line which is equidistant from the parallel lines 9x plus 6y minus 7 equal to 0 and 3x plus 2y plus 6 equal to 0. So earlier I also told you that what is the means how will you recognize that the two lines are parallel. You can always make the coefficients of x and y same. Like if I divide this by 3, you will get it as 3x plus 2y minus 7 by 3 equal to 0. And the second equation given here is 3x plus 2y plus 6 equal to 0. So just the difference is between their constant terms. Okay, so a line if is parallel to both 1 and 2, then its equation is your 3x plus 2y plus k equal to 0. Okay, so first is this your equation 9x plus 6y minus 7 equal to 0. Second is your 3x plus 2y plus 6 equal to 0. Okay, and this is your 9x plus 6y minus 7 equal to 0, which is same as your 3x plus 2y minus 7 by 3 equal to 0. Okay, and some another line is there whose equation definitely this is 1, this is 3, okay, this is your 2, this is 2 and this is 3, the third line, which we are taking it as 3x plus 2y plus k is equal to 0. Okay, now according to question, what is the condition? That distance between, okay, distance between 1 and 3 is same as 3 and 2. So how will you you know the distance between parallel lines? The formula of distance between parallel lines is c1 minus c2 upon your 1 plus n square. M is the slope. You know the slope of parallel lines is same. So let us recognize what is c1 and c2. So according to question, distance between 1 and 3 is same as distance between 2 and 3. And I need the slope also. So let us check the slope here also. So slope here is your y is equal to 7 minus 9 and divided by 6 and minus 9x this also by 6. So slope of this line 1 is, your slope here is minus 3 by 2. Slope of another line 2, as the lines are parallel, so slope is same. Let us check, is minus 6 minus 3x and this is by 2. So we get the slope here as same. So this was just for checking purpose. So slope is always coming out to be minus 3 by 2. So m here is 3 minus 3 by 2. So according to question, let us apply the distance formula. Who is C1 here? If I am applying the formula between 1 and 3, so C1 is the constant term of this, which is your minus 7 by 3, and this is the constant term here is k. So according to question, your minus 7 by 3, okay, C1 minus C2, this upon root 1 plus m square is minus 3 by 2 whole square. I think we don't need to solve it, as both sides it is there and it will be okay. And between these two, 2 and 3, it will be your k minus 6 whole square. Okay, k minus 6, right? And denominator not whole square. This is 1 plus minus 3 by 2 whole square. Okay, now let us open it. 7 by 3 minus k is equal to, we will take plus minus to other side. So plus minus here, k minus 6. Okay, so once I will take the sign of plus and once I will take the sign of, okay, minus 7 by 3 plus 6 is equal to 2k. This is 11 by 3. So k is 11 by 6. Okay, we get 11 by 6 here, right? So and let us check it to this side also. Minus 7 by 3 and it is minus 6, which is your, it will be your minus k plus k, this will be 0. So I think we are just getting your k is 11 by 6. So let us put it here back in this equation number 3. So I get the equation of 3 becomes 3x plus 2y plus k here is 11 by 6 equal to 0. Or you can just change it as 13x plus 12y, 18x plus 12y plus 11 equal to 0. Passing through the point 1, 2, reflects on the x-axis at a point A. Okay, so suppose this is your x-axis, a ray of light which is passing through, suppose point 1, 2. So if this is my axis, so a ray of light which is passing through, say somewhere here, point 1, 2 is there, it reflects back on x-axis. So suppose a point is there on x-axis, definitely whose coordinates are of the form x0. Okay, because on a point on x-axis is of the form x0. Okay, is reflected back. So this is your normal. Okay, reflected and passes through the point 53. Okay, right? So angle of incidence is equal to angle of reflection. Everybody knows that this angle is your 90 minus theta and this angle is also 90 minus theta. Okay, right? So let A coordinate x0 is a point at which, you say this is P and this point is Q, at which your line or ray, we are having a ray through 1, 2 reflects through point 53. Okay, now let us see what is the slope of AQ. Okay, So slope of AQ, slope, you can take the angle which is makes it the positive direction of x-axis. So AQ is making 90 minus theta, so which will be tan 90 minus theta, which is cot theta. Okay, and slope of AP, which is your, it is making an angle of 90 plus theta. See, AP is making, this is 90 and this is theta. So let me show it clearly to you. It is this complete angle. Okay, so this one is 90 and then plus theta. Okay, so the angle here is tan 90 plus theta, which becomes minus cot theta, as we are in your second quadrant, and in second quadrant everyone else sine and cosecant are negative. Okay, and tan changes to cot. Now according to question, your slope of AQ plus slope of AP is equal to 0. Okay, slope of AQ plus slope of AP is equal to 0. That means if I apply the slope of, means, or I can take it as that they are mutually, you can see here what is the angle between them. Okay, right? So slope of AQ plus slope of AP is equal to 0. You can clearly see from here, cot theta minus cot theta is equal to 0. This condition arises from here. So by using 2-point form, what is the slope of AP? y2 minus y1 upon x2 minus x1. Okay, so this becomes as your AQ, slope of AQ is 3 minus 0 upon 5 minus x. The slope of AP is your 0 minus 2 or 2 minus 0. You can take from that side also, upon 1 minus x equal to 0. Now the question is solved. So 3 into 1 minus x plus 2 into 5 minus x equal to 0. So 3 minus 3x plus 10 minus 2x equal to 0. So 13 minus 5x equal to 0. X is 13 by 5. So the point here is having the coordinates 13 by 5, 0. Question number 23 says, prove that the product of length of perpendicular drawn from this point, and suppose this is this point, to this line is p square. Now you know what is the formula for length of perpendicular from x1 y1 to the line ax plus by plus c equal to 0. It is given by ax1 plus by1 plus c upon under root a square plus b square. Okay, now given equation is x upon a cos theta plus y upon b sin theta minus 1 equal to 0. Okay, now compare it with ax plus by plus c equal to 0. A we get 1 upon a cos theta, b we get 1 upon b sin theta, and c here is minus 1. Now perpendicular distance, suppose I take this as 0.1 and this as 2. Okay, or we are taking this as equation 1, so this let's take it as 2 and 3 as indicators. So perpendicular distance from point 2 from equation 1 is supposed denoted by t1. So let us apply the formula. So this is the point, this is 1 upon a cos theta into root a square minus b square and plus 1 upon b sin theta. It will be multiplied with 0 because this by 1 is this, and minus 1 upon under root 1 upon a square. This is actually a square plus b square. So 1 upon a square cos square theta plus 1 upon b square sin square theta. Similarly, d2 will be from this point. So the only difference you will get is the minus sign here This I will take as 0 and this is as -1. Sine square theta. Okay. Now according to question, what I need to prove is that the product of these two is equal to b square. So let us take the product of d1 and d2. Now this question is more of trigonometry. Cos theta root a square minus b square minus 1. This inside, and say if I take negative common sign common out of these, it will be minus times 1 upon a cos theta root a square minus b square, and that is your plus 1 upon 1 upon a square cos square theta plus 1 upon b square sin square theta. Okay, and when it will be taken out of mod, right, this negative sign will be balanced, means we will just take it as like here this sign we need not take, because if I taking it out of the mod, we'll just take it as mod magnitude will give you just this as 1 upon a cos theta root a square minus b square plus 1 upon root 1 upon a square cos square theta plus 1 upon b square sin square theta. So it is just a square minus b square plus 1. Okay, right, and denominator will just contain, as it is same term with the root, so I will just get at whole square 1 upon a square cos square theta plus 1 upon b square sin square theta. So numerator is more of a plus b and a minus b, which can be 1 upon a square cos square theta, okay, a square minus b square, and this is minus 1, a plus b into a minus b is this, and this is your b square cos square theta plus a square sin square theta, and it is a square b square. Let's take the LCM in the numerator and split the terms a square cos square theta minus b square cos square theta minus a square upon a square upon b square cos square theta plus a square sin square theta upon a square b square. Okay, now see, this b square will move at the top, and as you see in this numerator and denominator, this is your b square cos square theta plus a square sin square theta. Okay, so I will take it as minus b square cos square theta, and from these two I will take a square common, so plus a square, and it will be, okay, I want to make it as sin square theta, so I will take, say, minus sin common, minus a square 1 minus cos square theta. You just see it is minus a square like this, and minus a square, okay, and this is minus minus plus a square cos square theta. Okay, so this is like this, and b square cos square theta plus a square sin square theta. So this is your b square. Okay, still we are just in the process of magnitude, because we are taking the product of the distances, so the result will be just in positive. Okay, so this is your if I take out the negative sign common out from here, it will be, you see what will it be, it is b square cos square theta, and this is 1 minus cos square is sin square plus a square sin square theta. Okay, see, b square cos square theta plus a square sin square theta. As we are taking the product of the distances, we are just going to consider the magnitude. So when this minus b square will come, it will come out as b square. Question number 24 says that a person standing at the crossing or junction of two straight paths, this one and this one, wants to reach the path in least time. Find the equation of path that he should follow. So a person is standing at the crossing of these two lines. This one is So means this is the point of intersection of these two lines, and this is the path, and the person wants to reach this path in the least time. So means I should draw a perpendicular. Okay. So how will you find the equation of this perpendicular? I just need the slope of this line and this point of which I will get from the intersection. And the slope is easily can be obtained from this line, as this is perpendicular to this line. Okay. So this is number 1, number 2, number 3. So here slope of 6x minus 7y plus 8 equal to 0. Let us express it in the form of slope intercept. Okay, can be written like this if I divide by 7. So slope is 6 by 7. Now slope of PM will be negative, a reciprocal of slope of line 3. So which is your minus 1 upon 6 by 7, which is minus 7 by 6. Okay. Now what do we get? That let us find the point of intersection. So point of intersection of equation number 1 and 2. Let us equate the coefficient. So multiply this equation by 3 and this by 2. So it will be 6x minus 9y plus 12 equal to 0. 6x plus 8y minus 10 equal to 0. Minus this. So it is 17y plus 22 equal to 0 implies y is equal to minus 22y. Yeah. This becomes minus 17 is equal to minus 22. So it is 22 by 17. Okay. Now x I will get. Let us put it in some simple equation. 4 equal to 0. So 2x is equal to minus 4 plus 66 by 17. So 68 plus 66 by 17 minus 2 by 17, and x I will get as minus 1 upon 17. So I got the point as P as minus 1 by 17 and 22 by 17. So equation of line passing through this point and having slope here minus 7 by 6 is y minus y1 m times x minus x1. Okay. So 17 by minus 22, this multiplied by 6 is equal to, okay, upon 17, and here it will be minus 7 into, let us take the LCM from here also, 17x plus 1. Okay, 102y minus 132 minus 119x minus 7. So 119x plus 102y. Okay, so this is your 102y. Okay, and this is minus 125 is equal to 0.